Okay, so today we're going to be finding the equation of the tangents at a given point for an implicit function. Sounds quite complex, but let's break it down and we'll be able to go through it quite easily. So I have an implicit function here. Y isn't the subject. We have x's and y's on the same side of the equation. That's what implicit means. Now, if you haven't seen my video on implicit differentiation already, I really recommend you see it because we are going to need to differentiate this. But if you have seen it, let's dive straight into it, and let's use implicit differentiation to find the dy over dx for that. Okay, so first off, we have just our ordinary function. It's always good to write it out, so that way you can scribble all over it, as I'm about to do. And what we want to do is we want to take this term here and we want to differentiate it. So what we do is we move the exponent of 2 down to the position of the coefficient, which is 1, and we get 2 times 1, which is just going to be 2. And then we have y to the power of 1, because we subtract 1 for our exponent, and y to the power of 1 will just be y. So y squared becomes 2y. Now we need to use the product rule on this term here, because it's negative 3x times by y. So first off, we need to take the derivative, we need to differentiate our first term. So negative 3x is going to become just negative 3. And we can see that because that's x to the 1 there. When we take that 1 and we multiply it by a coefficient, which is negative 3, get negative 3 times 1, which is just negative 3. And then that's x to 0 because we subtract 1 from the exponent, so it's just negative 3. Then we write the second term as is, so it's take 3y. And then it's take, because operation there is a negative. And then we just write 3x as it is, but then we differentiate our second term this time around. And y prime, when you implicitly differentiate, is dy over dx, because we're differentiating with respect to x. Then, lastly, we differentiate this term. So we move that 3 down to the position of the coefficient, so exponent to coefficient, and we get 3, because 3 times 1 is 3. Then we have x, and we subtract 1 from our exponent, so it's x squared, and that all equals 0 because the derivative of constant is 0. Just think about it as a horizontal line. If I were to graph, say, y equals 3, it would just be a flat line, no change in y or x. So there we go. Now what we need to do is we need to be able to write dy dx as a subject because we want to find the derivative of this equation. So what we do is we identify terms that have a dy dx in them, and let's see, this one, I forgot to put dy dx there, sorry about that, but it should be dy dx because there's a y involved and we need to differentiate with respect to x. So if that's the case, this term has a dy dx, that's negative 3y, so that doesn't have a dy dx, and this doesn't have a dy dx, but this term does. So we're going to put dy dx out the front on the left-hand side. Remember to watch my implicit differentiation video if you're having any troubles. And we have 2y take 3x. Because we've just moved that dy dx, the common factor, out the front, and then we filled in our brackets with the terms that have dy dx in them, or did have in them. Now we need to move the terms that don't have dy dx in them over to the right-hand side of the equation. So, and we need to inverse their operations when we do so, so we get negative 3x squared, and then it's plus 3y. And then our next line is to simply put dy dx as a subject equation, so move this from the numerator on the left-hand side to the denominator on the right-hand side. So you get dy over dx equals negative 3x squared plus 3y all over 2y take 3x. And there we go, implicitly differentiated. Now we go on to our next stage, and that is to find what y equals in this equation. So x equals negative 1, as we know, and we know that y squared take 3xy plus x to the 3 is going to equal 3. So what we do is we substitute in our x value, negative 1, so you get y squared, take 3 lots of negative 1, y, plus negative 1 cubed equals 3. Now, sorry I'm sort of going all over the place. There is a lot of board work involved with this. But what we do next is we have y squared, and we can simplify this. Negative 3 times by negative 1 is always going to be equal to 3. So we have plus 3y there. And then we need to add negative 1 cubed. Now, negative 1 times negative 1, which is negative 1 squared, is going to be 1. If we times that by negative 1 again, we're going to get negative 1. So 3y. Take 1 equals 3. And therefore, what we do now is we can move that 1 to the other side. So we get y squared plus 3y equals 3 plus 1. Again, we inverse the operation as it goes to the other side, so that all equals 4. Now what do? Well, we work out how we could fit y into there. So I'll come up here, and we've got y squared plus 3y equals 4. Now, y1, that's going to be our first y value for our coordinate pair. So we're working out what are our y values when x equals negative 1. So if that's the case, our y1, let's have a look at this here. If we have 4 there, and we've got the number 3 there, and then we've got something squared, I can immediately start to picture that 1 would be there. You can use simultaneous equations for a more difficult question. I may do a video on that later, but we can see that 1 squared plus 3 lots of 1 does equal 4. So one of our y values will be 1, so that means that one of our points, if I were to write it here, would be negative 1, 1. Then we need to find out our y2 value, which is what our y also equals when x equals negative 1. So if that's the case, again, we've got y squared plus 3y equals 4, and we want to find what else y can equal. So 1 was the most obvious one. Let's have a look. Is there anything else we can do here? Generally, you can use simultaneous equations, but I can see here that maybe we could use a negative y value and just check to see. So if this is the case, if we've got 3 lots of something equals 4, and we've got y squared there, then a negative times a negative is going to make a positive, so that's going to make a reasonably large number. If we had, say, I'm just looking at this, I can see that negative 4 emerges, so if we have negative 4 squared, that's going to make 16, and then plus 3 lots of negative 4, that's going to be 16, take 12, which is going to be 4. For more difficult ones, you will need simultaneous equations. We'll do a video on that later, but that means that our other y value is going to be negative 4, so we get negative 1, negative 4 as being another point in our set. Now, I'm going to probably do a second part to this video, because there's still a decent amount of stuff we need to go through. Hopefully you understood it so far. We just differentiated. We've just rearranged the equation a little bit to be able to get x values when x equals negative 1, to be able to solve for our y value. And we've worked out our points, and I'll tell you what to do with the points in the next video. But that's all we've done this video. Hopefully it makes sense. Hopefully you understood it. Again, if you didn't understand it, see the implicit differentiation video. It will probably help you make a lot more sense of it. But part 2, we should be able to finish this off, so I guess I'll see you then.